Okay, today we're going to talk about enthalpy. This will be split into two videos because YouTube will only allow me to upload videos up to 15 minutes long each, and I think the two parts will take longer than 15 minutes to record, so I'm going to split it in two. The first one will be about enthalpy, the background of what it is, some definitions, how to draw graphs, things like that. The second video will be sort of the more math side of it, so Q equals mc delta T calculations and some experimental ways of finding out the enthalpy of a reaction. So if we start on the first video, enthalpy. Enthalpy is a measurement of energy in a thermodynamic system. It's given the letter H. So when a reaction happens, energy is transferred. So for example, there are two types of reaction, an exothermic reaction, which is where energy is given out, and an endothermic reaction, which is where energy is taken in overall. So you need to know how to draw these diagrams that you see below, the exothermic and endothermic one, and I'll tell you how and what everything relates to. So on the y-axis you have energy. On the x-axis you have reaction progress or reaction coordinate, however you would like to label it. Now, what you have in reaction is you have reactants go to products, and there's an activation energy in there. So for exothermic, as you know, overall energy is going to be given out. So for example, if you had a reaction between X and Y goes to A and B, the energy given out is minus the enthalpy change is minus 20 kilojoules. The minus indicates that energy is given out, whereas if it was the enthalpy is plus 20 kilojoules, it's endothermic as energy is being taken in. So if it's exothermic, you put reactants higher than products because there's an overall decrease in energy. What you then do is you draw this shape here. Basically what this means is that there's an activation energy, which is this. Activation energy. And if you don't know what that is, basically what it means is that bonds have to be broken to form the individual atoms, which is this bit of the curve up here, and that's how much energy it takes, called the activation energy. And then new bonds are formed to make the products, which this is the energy that it takes. So it will take some energy to break the bonds, and then some energy will be given out to make new bonds. This means that you can do the energy given out minus the energy taken in, and you can get an overall energy, or the enthalpy change, which is delta H, indicated by this orange arrow here. So energy taken in to break the bonds, energy given out to make the new bonds. You've got an overall enthalpy change here. The activation energy is the energy required to break all those bonds to this point here, or as some people might know it as to form new intermediates. So endothermic is almost the opposite. As you know, if you know it's endothermic by a positive symbol on the enthalpy change of the reaction, then that means it takes more energy to break the bonds than it does to make new ones. So a lot of energy is taken to get to the activation energy, breaking the bonds, and less energy is given out to make the new bonds. So therefore, the activation energy is extremely high, and you've got the overall enthalpy change there. So that's how you would create one of those diagrams. So you get your reactants and your products. If it's endothermic or exothermic, it depends which one is higher than the other. Then you draw this curve. It's a similar shaped curve for each one. And then it's between the reactants and the peak of the curve is your activation energy, shown by the green arrows. And then the difference between the reactants and the products, shown by the orange arrow, is your enthalpy change. Now usually with exam boards such as OCR, you don't have to give it to scale as in exact numbers. However, if it's endothermic, reactants must be below products. If it's exothermic, reactants must be above products, just to show it in a general way. Okay, so there are different definitions for different type of enthalpies. There are 4 I know for the OCR board that you need to know. But first of all, before we do that, we need to understand that all these happen under standard conditions. Standard conditions, as you can see in green here, are 100 kilopascals, which is the same as 1 atmosphere of pressure, which you're probably sitting or standing in right now. 298 Kelvin, which is the Kelvin scale for 25 degrees C, 25 degrees Celsius, which is roughly room temperature, maybe a bit hotter than room temperature. And for solutions, it must be 1 mole per dm cubed, or a 1 molar solution. And these are so scientists can have a standard between everything that they're conducting, so they're all fair when you compare the numbers. So the first one that you need to know is called enthalpy change of reaction, or delta HR, which delta is the mathematical term for change in, so the change in enthalpy, H is enthalpy, now little r stands for reaction. And if you look at the one below, you've got a little f, which stands for formation, and you'll see a couple of others later. So delta stands for change in, H enthalpy, and the little subscript there will indicate what one it is, such as reaction, formation, combustion, etc. So enthalpy change of reaction is the enthalpy change associated with a reaction. So, for example, you could have hydrochloric acid reacting with magnesium oxide, and that would go to magnesium chloride and water. Now, this reaction here will have an enthalpy change related to that, as there's energy to break the bonds that goes in and energy to make new bonds that comes out. And because it's a reaction, it's delta HR. So the next bit is enthalpy change of formation, the second one down here. So that's defined as the formation of 1 mole of a compound from its elements. So this means that you could have solid carbon, like soot or graphite or something like that, would react with gaseous oxygen, because in standard conditions at room temperature, oxygen is a gas and carbon is a solid. They'll react to form carbon dioxide as a gas. Now, there is an enthalpy change there of formation, as you're going to have to put energy in for it to react. So, for example, you put a solid bit of carbon and just some oxygen in there, it's very unlikely, or it doesn't react very fast or something like that, and you can measure the amount of energy that it takes to form carbon dioxide. So, the next two definitions are enthalpy change of combustion and enthalpy change of neutralization. Now, enthalpy change of neutralization is the bottom one, so we'll start with combustion. So enthalpy change of combustion is the enthalpy change of complete combustion of 1 mole of a substance. So, for example, CH4 and oxygen can react to form carbon dioxide and water. And we just quickly balance that up. That requires, and water, so that requires 4 oxygens, carbon dioxide and 2 H2O. There we go. So that would be an enthalpy change of combustion, and just remember that it's 1 mole of the substance and still under sort of standard conditions. So neutralization is the enthalpy change from formation of 1 mole of water from neutralization. So when 1 mole of water is created from a neutralization reaction, which, as we may know, it's sort of an acid and an alkali. So if we have hydrochloric acid reacts with sodium hydroxide, we'd get a reaction that goes to sodium chloride and water. So there you have an enthalpy change of neutralization, because again bonds are breaking from the HCl and NaOH to form new NaCl and H2O bonds. So that's the first bit of the video. The second bit of the video will go on after and be labelled part 2. I will put a link in the description to that as well, so feel free to watch it, and we'll be going over Q equals mc delta T calculations, what it all stands for, how you do the calculations, some examples, and then also experimental ways to find the value of Q. Thank you for watching this video. Please watch part 2, subscribe and share to your friends, and like this video. Let me know in the comments below if there's anything you want me to do that I haven't covered already, and I'll do it ASAP. Thank you.